So hello again and welcome to this recording. So I'll be solving one of the exercises which is about golden ratio. So we have two series, so U and V, and U is defined as the first term is equal to 1, the second term is equal to 2, and the consecutive terms are equal to the sum of the two previous terms. And then we have the series V, which is equal to the division between two consecutive terms, ui over ui minus 1, and I here should be greater or equal to 0. So we say that V, it tends to a limit which is called the golden ratio. So obviously it's a series of V, so we need to calculate multiple terms in order to so as if I were taking the infinite term, but however in our case we cannot have infinite. So we suppose that the nth term, so whenever I is equal to n, the term of the V series, so Vn, will give an approximation of the golden ratio with a precision E. It means that whenever the absolute value of the difference between Vn and Vn minus 1 is less than a precision E, then Vn would give the answer of the golden ratio. So they're asking us to write a program that prints the golden ratio, that prints Vn and the rank n. So we need also the value of n here in the series with a precision E given by the user. So the user will given the precision E. So we need to do the calculation until this value is less than E, and then I need to print Vn and I need to print n. So the output is two numbers, an integer corresponding to the rank n, so it's n, and the value of Vn. So this is the input, which is E, it's a double, and I need to output n, which is an integer, and the golden ratio, which is a double. So let's first work incrementally. So let's start by, so before calculating V, let's start by calculating U. So it's a common example, which is the Fibonacci sequence. So if I have U1, so let's call it the first term is equal to 1. So let's write it here. And then U2 is equal to 2. So the next term U3 is equal to the sum of the two previous terms, which is equal to 3. And then I have 2 plus 3, which is equal to 4. So obviously, if I want to do that using a loop, so this one will become U1, this one U2, and this one U3. And at each time, I'll be summing the U1 and U2. So at each iteration, I will place the value of U2 in U1 and the value of U3 in U2, and then I will do the calculation of U3, which is equal to U1 and U2. So I will start with that, and then I will continue by calculating the V of I. So the input is a double. So let's say that I will read it. So it's a double E. And obviously I will need some other variables, and I have scanf, percentage LF, and the address of E. So I will do that because just to have the input. And then I need to loop and output UI. So obviously I need values of U1, U2, U3. So double U1, U2, U3. So, and since I don't know when I need to finish because I didn't calculate it yet Vn. So let's suppose I will use a loop just to print and to be sure that I'm doing the right calculation. So I will loop like 10 times and print the values 10 times just to have the first 10 iteration of this calculation. So as I have said, at first let's initialize those. So U1 equal to 1. And U2, as it's written, is equal to 2. And then at each iteration, I should do U3 equal U1 plus U2. And as I have said, I will go back. I should place U2 in U1. So U1 would be equal to U2. U1 equal U2. And in U2, I should place the value of U3. And at each time, so I will print F here the value just to see it on the screen. So this is the first term, this is the third term. So I can start from 3 just to print on the screen U percentage D. It means U3 equal percentage D backslash N. The first one is I. So it's the term, the nth term, and then the value which is in U3. So this is just to see the output. So let's pre-check. I don't know if there's an output in the pre-check, but at least we can try. So I have here percentage D, I have here double. So let's say LF. So we have just pre-check, and yes, we have 3, 5, 8, 13, 21, 34, and 65. So yes, this is the sequence. So they are the sum. So here we have 5. 3 plus 5 is equal to 8. 8 plus 5 is equal to 13. 13 plus 8 is equal to 21. 21 plus 13 is equal to 34. And 34 plus 21 is equal to 5 and 5. So 55. So if I continue, it will be equal to 89. So and so on. So at the first part, I have reached to calculate u of I. And then, so at each iteration, I need to find the value of vi. So vi is equal to ui over ui minus 1. And since I need to compare two values of vi, so if I come back here, so let's start again. So I have, let's remove this. So I have the sequence, which is equal to 1, 3, 1, 2, 3, 5, 8, 13, 21, and let's stop here, 34. So I know that vi, it starts from I equal to 3. So this is u1, u2, u3, u4, u5, u6, u7, and u8. So I can start with v3, which is equal to u3 over u2, which is equal to 3 over 2, which is equal to 1.5. And then I can calculate v4, which is equal to u4 over u3. So u4 is equal to 5 over 3. So obviously it will be less than 1.5. So let's say calculator, it's more than 1.5. So 5 over 3, it's equal 1.66. And so on. So at each iteration, I should calculate the difference between the absolute value of v4 minus v3. So here it would be equal to 0.166. So, and this one, whenever the value of this difference is less than the precision here, I would output the value of v n and the value of n. So obviously, in order to do that, I need two variables to calculate the v3 and v4. So for that, I will use the value of, so I can use v3, v4, or I can use v2, v3. So it depends on what you want. I will use v3 and v2 because I will start with v3. So obviously, I will not start the loop without having two values. So I will calculate v3 outside the loop because I need at least one value, and then inside the loop I will calculate the v4. So I should have at least at first v3, because I cannot loop, I cannot calculate this value because this is the stopping condition of the loop until I have, so I should have v3. So for this, I will use double v3. So this is my first variable, and I will calculate it outside the loop. So I have here u1, u2, and obviously I should calculate one time u3, because if I want to calculate v3 outside the loop, I need to have u3 over u2. So v3 would be equal u3 over u2. So I have the first term of the sequence here. So for now, I will skip the counter here, the number n. I will just do the calculation, and then we will modify the program. So now I know what the loop would be. So the condition would be if the absolute value of v3, so this is the calculation of v3, and of course I need also another variable. So this is why I will call it here v2. So v2, I can either use v2 equal v, let's write it here, it's equal u2 over u1. So this is the term that we will consider as the first term, and as long as those terms are greater or equal to the precision e, I will iterate. So what does it mean, iterate? Obviously, I will be calculating all these values. It means u3, u1, and u2. So obviously, I have calculated u3 here. So there's no need to recalculate it because this is the last term. So I will move it till here, and I will do the modification there. So at each iteration, I have, so if it's not the case, obviously, I need to recalculate v3. So I will calculate u3, and then I will calculate v3, which is equal to u3 over u2. So I will repeat it again. Once I write the code, I will show you the calculation there. So I have calculated the use, so I have modified this, so it was there. I move it here because I already calculated u1 plus u2. So I have updated both values and then calculated the newest value of ui. And then whenever I have calculated ui, so now I can calculate the newest value of v. However, I need to update the oldest value. So as if we are doing here, we are updating u1 and u2 by the previous value. So obviously in v2, I should place the oldest value, which is obviously it will be equal to the same because I have modified those values here. So first I will save the old value v3 over v2, and then I will do that. So let me explain it here. So we call it, let me rewrite the sequence. So it's equal 1, 2, 3, 5, 8, 13, 21. So this is u0, u1, u2, u3, u4, u5, and u6. So we have declared v2, which is equal to u2 over u1, and then we have v3, which is equal to u. So we have here u1, u2. Sorry, we didn't start from 0. So v2 is equal u2 over u1, and v3 equal u3 over u2. And we are always doing the absolute value of v3 minus v2. So at first, the first iteration, v2 is equal u2. And at the second iteration, we have v2 here, which would be equal u3 over u2. And then v3 would be the next term, which is equal to u4 over u2. So before modifying v3, I need to copy its value and place it in v2. So before modifying u2 and u3, because u2 and u3, they are the variables that I'm using always, so there are those two variables that I'm using. So I need to copy the value of u2 over u3 over u2 and place it here into v2. And then I will calculate the newest value of u3 and u2, and I will calculate the newest value of v3. So this is the idea. So if you understand how we have we wrote the UI, so the VI, they are the same, but they are a bit more complicated. So we will stop whenever this difference is greater or equal to 0. So let us print the value of V3, because this is the value that we want. So LF, and I will print E. So let's pre-check. So obviously I will not have an answer because there is no input, so I'm not using I anymore. I can remove the variable I from my code, and I will do a pre-check again. So don't abuse using modulo. So we have a lot of modulo here, I don't know why. So I will do a check. So in my check, so they are telling us please don't abuse using a modulo. However, I'm just using two modulo here. So maybe we should use one more because I need to print the term. So let's say %d, and I will print the value 1 for now, and I will do a check. So I should get 1.6, and I should get 1 here because I didn't calculate the 1. So obviously I didn't get the value. So I have the precision here. I have the value that should be equal to 1.6. However, I have printed E. I should have printed V3. So my mistake. So obviously I have got the same answer of Vn. However, what's still missing is Vn. So it means at which iteration I have found that V3 minus V2 is equal to this number. So obviously I need to count the number of times I have done this. So for that I will use a counter. And obviously, whenever I'm doing those modifications, it means that I move to another term, I do a count. However, I need to start with a number. So they are telling us that this one is true whenever I is greater than 3. So I know that here I have calculated V3. So I have started from count equal to 3. And let's see if it will work. So I started with 3 because I have calculated the term U3 over U2. So I have still until here I have calculated the term V3. So I should output count. Let's check. and obviously I have got the correct answer. So let me repeat quickly. So we have read the precision. So we have previously calculated. So we have tried to calculate U's first. So we know that we need to loop, and at each iteration, the third term is equal to the sum of the two previous terms. However, while looping, I need to update. So I will repeat it here. So I have 1, 2, 3, 4, 5, 6. This is U1, this is U2, and this is U3. So U3 is always the sum of U1 plus U2. However, at the next iteration, this is U1, this is U2, and this is U3. So I need to place the value of U2 in U1, the value of U3 in U2, and then I need to do the calculation. The same applies for the series V. So VI is equal to UI over UI minus 1. However, I need two terms. So I need to, since they are asking us to do the difference between two consecutive terms. So I have used two variables called V3 and V2. So let's suppose that the terms, so this is V0, this is V1, V2, V3, V4, V5. Those are the values of the original series. However, in my code, I have just two V's. So I have V2 and V3. So V2 is equal, in our case here, the first U1 over U2 over U1, and V3 is equal U3 over U2. And then I need to move. So I need to move those values one step. So V3 would become V2 and V4 would become V3. So obviously the value of V3 should come into V2. So the value of V3, which is equal to U3 over U2, should come into V2. So you can write here V3 if you want. It would be the same. So you can move the value of V3 into V2, and you need to recalculate the value of V3, which corresponds to V4, which is equal to U4 over U3. So for that, you need to calculate the new terms of U, so U3 and U2. So we are doing this here, and then we are using them into the new calculation. So let me just check to just verify that it works here. So obviously it will work because I'm saving the oldest value of V3 into V2, and I'm recalculating a newest value of V3 based on the new calculation of U. So, and this is the solution. You just need to pay attention that you need to calculate some of these values beforehand, because I need two terms, so at least I need to have two terms. As for the counter, so we need to count the number of iterations, knowing that we have calculated V3 till here. So obviously I have the term n equal to 3, so I will increment it, and whenever I'm out of the loop, it means I have found the term of the series, and we have also found the golden ratio. And this is it for this exercise. If you have any question, do not hesitate to write to me and I will answer you back. And do not forget to subscribe to my channel and to hit the bell icon to receive all the notification. And again, thanks for watching.